Hi, I'm Giancarlo Ayan, and I'm going to discuss all about the Gauss-Seidel method. I will going to discuss about the basics and an example of Gauss-Seidel method. So let's start. So what is Gauss-Seidel method? So it says here that Gauss-Seidel method is a technique for solving the n equations of the linear system of equations. Ax is equals to b one at a time in a sequence and uses previously computed results as soon as they are available. So therefore we really going to use an iteration, and we have an initial guess. Of course, the initial guess depends on you guys. So next is the diagonally dominant, which will be used later on. So we have three equations. So the first equation is 5x1 minus x2 minus 2x3 is equals to 12. 3x1 plus 8x2 minus 2x3 is equals to negative 25. And x1 plus x2 plus 4x3 is equals to 6. So first, we are going to get the DD, or the diagonally dominant, and equate it to the sum of everything on the left side of the equation. So we get 5 is greater than negative 1 plus 2. It's obvious. Next is 8 is greater than 3 minus 2, which is 1. And 4 is greater than 2. So which is all true, so we're going to proceed. So set the equation first in where we can isolate x1, x2, and x3. So in this equation, we have just transposed the values from the left side to the right side. So we have x1 is equals to 12 plus x2 minus 2x3 over 5 all over 5. X2 is equals to negative 25 minus 3x1 plus 2x3 all over 8, and x3 is equals to 6 minus x1 minus x2 all over 4. So for our first iteration, I of 0, I will set an initial value of my choice. So I want to set x1, x2, and x3 to 0, 0, 0, then equate it to the three equations. As we have said, iterations means the repetition of the mathematical or computational procedure applied to the result of the previous application. So in short, we're going just to update the xn from the result. So here's an example for you to understand more. So the first is, we have an initial guess of 0, 0, 0, and we're going to plug every x1, x2, and x3 to the equation x1. So we have 12 plus 0 minus 2 times 0 all over 5, which is going to give us 12 over 5. Since we are having an iteration, so we're going to replace the previous x1 as the latest x1. So our latest x1 is 12 over 5. So we're going to replace 0 to 12 over 5. Next, for x of 2, so we have negative 25 minus 3 x of 1 plus 2 x of 3 all over 8. So if we are going to notice, the x1 has been already replaced by the latest value of x1. So it gives us negative 25 minus 3 times 12 over 5 plus 2 times 0 all over 8. So which is going to give us the result of negative 161 over 40. So we're going to do that step to x3. So we are going to obtain 6 minus 12 over 5 minus negative 161 over 40 all over 4, which is going to give us 61 over 32. So the next step is to get the percentage error. Our formula for the percentage error is the error percent is equal to the true value minus the accumulated value all over the accumulated value times 100%. So the TV minus AV over AV is in absolute value. So in here, for the first error, for the first percentage error, we have 0 minus 12 over 5 over all over 12 over 5 times 100, which is going to give us 100%. Since we have an initial guess of all 0, so we are going to expect 100% error in everything that we have done. So let's continue to the second till the third iteration. So for the second iteration, we have the new x1, x2, and x3, which is 12 over 5, negative 161 over 40, and 61 over 32. So we're going to do the same thing as what we have done at the first iteration. So we're just going to plug in the x1, x2, and x3, and the iterations of each x1, x2, and x3 will be replaced as soon as it is updated. So in here we have the percentage error, and we have a large error at the first x. So we have 188.28% error. As we move on, we have noticed that the error percentage has decreased from 188 to 16%, and the others also decreased in percentage. So that's how easy it is to use the Gauss Seidel method. So that's it for today, and thank you for watching.